Welcome to News 130, Multimedia Design. This is Lesson 2, Design Basics. Today we're going to look at the fundamentals of graphic design regardless of what the application is, whether we're designing for something that's more web-based, more print-based. There are some core elements that are universal across all kinds of graphic design applications. So today we're going to look at two different kinds of graphics. We're going to look at color theory, digital color models, measurement in graphic design, and typography. Graphics in a very general sense are the visual components of digital communication. Regardless of whether we're designing for a website or a newspaper or some other medium, graphics are there to help explain the story, to help embellish the story, and to provide visual communication. And so in our world, in the digital world, graphics require manipulation. They require that we create them or engineer them on a computer using proprietary or open source software, and that we understand the differences between different pieces of software and how they understand graphics. When engineering graphics on a computer, it's important to note that there are two different ways that computers understand graphics when you're making or manipulating them. You'll see on this slide that there are two yellow circles that look the same, but when zoomed in, you can clearly see differences in these circles. The black line on the vector graphic when zoomed in looks nice and smooth, while the black line of the raster graphic when zoomed in looks kind of smudged and blurry on the edges. Both vector and raster images have their pros and cons, which I'll discuss. The first type of graphic I want to talk about is vector graphics. In a broad sense, these are shapes. They aren't photos. They aren't detailed information pieces. They're shapes. If you think back to your middle school geometry class when you learned about grids and lines and shapes and you had to solve equations and then plot points and lines on a graph to draw a shape of some kind, that's what's being applied here to vector graphics. In the vector graphics system, computers remember what we've drawn by remembering the shapes. So to review, vector graphics are shapes. They can be polygons or circles. They're based on geometric primitives. They're infinitely scalable. When we create shapes in a program that uses vector graphics, we can blow them up or shrink them down, and the shape will maintain its shape and maintain its crispness. Vector graphics are also known as line work. Vectors are made up of three primitives, from which all other vector elements are created. A point defines a single spot in space, and again, if you think back to middle school math class, a point has an x and a y coordinate, and if you've ever had to plot points in 3D space, it may also have a z coordinate. A line is the connection between 2 points, and a curve is the connection between 2 points that arcs to some degree. So technically, a line is a curve, it's just a flat curve. But these three elements make up every other element in vector graphics. So here we have a shape made up of points, curves, and lines. It's a simple shape. It has points in 3 corners, 2 lines, and a curve. If you create 2 points and connect them, you've created a line. If you create 3 points and connect them, you've created a shape. There are several programs that are used to create vector graphics. The sort of de facto standard that most professionals use is Adobe Illustrator. Less popular but still widely used is CorelDRAW. Inkscape is an open source vector graphics program, which means it's free and available online. And Freehand is a now defunct program that used to be commonly used. Some people still use it, even though it's not being developed anymore. Some people have older copies that they still use. All of these programs create and manipulate vector graphics. Unlike vector graphics, which are based on information about shapes, raster graphics are based on pixel information. Pixel is actually a combination of the two words picture element. So those two words are combined and sort of truncated into the word pixel. Instead of remembering shapes, the program you're using remembers blocks of information known as pixels. So the smallest little dot of color a computer can possibly make on its screen is called a pixel, and it's in a square shape. Each pixel has a color and a transparency, and when those blocks of pixels are combined, they start to form an image. You'll see this if you stare very closely at a computer screen or a TV screen. Raster graphics are also sometimes known as bitmaps, or in the world of print are sometimes referred to as contones. Image resolution refers to how many pixels make up an image. So if a raster image is 72 dots or pixels per inch, it will have 72 pixels of information in every inch. In print, we generally use 300 dots per inch, which is a higher resolution. At 300 dots or pixels per inch, an image has much more pixel information and it can therefore be printed larger and at a higher quality. Vector graphics are typically used for charts, logos, and graphics, while raster graphics are more for photos. Here's a photo of a monument in the Philippines. I'm blowing up a section of it and you can start to see the pixels or the blocks of information that make up this image. And you can see how each pixel is one square that is a single color, but once we start to stack all those pixels up, we can create the color changes and the shadowing necessary to represent a photo on our screen. There are quite a few programs that will allow you to create raster graphics. The standard is Adobe Photoshop. There's also an open source program similar to Inkscape that allows you to create and manipulate raster graphics called GIMP. Now that we've made a distinction between two different kinds of software that remember graphics in two different ways, raster and vector, let's move on and talk about color theory. Color theory, our next component of graphic design, is the idea of how we can represent digital color on our screens as we create the graphics, and then how we can represent that color on other screens or print those graphics. All color theory is based on hue, saturation, and lightness. Your hue is what color we're working with, so green, light blue, brown, or here, red. Saturation is the intensity of that color, and lightness is exactly what that sounds like, how light or dark the color is. Regardless of how color is being manipulated across different systems, for digital screens and for print, color is a combination of these three elements. If you remember back to grade school art class, you probably remember learning about the primary colors, red, yellow, and blue. And you learned how you can mix those three colors in different amounts to make all of the other colors that the human eyes can interpret. In digital color manipulation, red, green, and blue are the core colors from which all the other colors are made. When we mix red, green, and blue, we create secondary colors. When we mix those, we get tertiary colors. If you keep combining and combining colors, you get a spectrum of all the available colors. This is illustrated by the color wheel. The color wheel therefore helps us to understand the relationships between colors. When designing, you want to choose a color scheme, and you want to choose a color scheme for several reasons. First of all, you want to limit the number of colors that you use on a single design so that you don't overwhelm the viewer with too many colors. Second, you want to create some harmony of colors so the design's colors match and they look like they go together. Schemes aren't a set of pre-chosen colors, those are called palettes, but rather a pattern we can apply to the color wheel to help us choose colors. So in a monochromatic color scheme, we choose one hue on the color wheel and we just add some black or white to it to make the hue lighter or darker, and our colors are guaranteed to match. But we also have some variety. If we take red, for example, and we add some white, we start to get pink. If we add black, we start to get a more burgundy color. So we have some light and dark to create contrast on our design, but since we're using just red, white, and black, we know this design is going to look nice. The colors are going to match and the design is going to look like everything in it goes together. In a complementary scheme, we choose colors across from each other on the color wheel. This gives us high contrast. Blue and orange, for example, are complementary colors. Because they're opposite each other on the color wheel, they're very different from each other, and so that creates variety. An analogous color scheme is made by choosing colors that sit next to each other on the color wheel. Here's an example of how we can apply these schemes to the color wheel. So in the monochromatic example, we've chosen a red hue, and then we're adding black to make it darker, and then we're adding white to make it lighter. We now have a range of colors we can use in our design. Well, we have a range of values we can use in our design based on the one color, red. We could easily take this idea of a monochromatic scheme and move it down to green and use green as our main hue, and then just add white and black to it to have a darker and lighter version of green. In the analogous example, you can see that we're choosing colors that are near each other on the color wheel. In this case, red and purple. Because purple has red in it, it matches red very nicely. And then in the complementary scheme, you can see we're choosing red and green, which are opposite each other on the color wheel and therefore have high contrast. We could also create complementary schemes by just taking this idea of opposites and moving it around the color scheme. So red and green are complementary, yellow and purple are complementary, blue and orange are complementary. There are many other color schemes. These are just three, but these three illustrate how color schemes can help designers. When creating graphics using desktop publishing software or any computer software, we need a system for communicating to the computer what color we want and for having the computer display it to us on the screen. I can't draw something in Photoshop and then just tell the computer I want it to be red. I have to say exactly which red I want to use. That way, the program knows exactly what color I want and can show the graphic on another screen or send the graphic to the printer with the exact color I want to use. When designing, there are three main color models that I need to be aware of. RGB is the most common. Each pixel is made up of a combination of each of these colors. There's CMYK, which is almost exclusively used for print and helps the printer to understand how much cyan, magenta, yellow, and black ink to put on a page to make the different colors. Finally, there's HSV or HSL, which is used in other programs, for example, digital video. In the RGB color model, you can have between 0 and 255 of red, green, and blue. If I have an RGB value of 0 red, 0 green, and 255 blue, then I have a pixel that is an intense blue. If I take that pixel and I change the RGB value to have 100 red, 0 green, and 100 blue, it's now going to be purple because I'm mixing red and blue equally. CMYK is based on percentage and again is used for print. HSV or HSL uses a hue to identify a color on the color wheel and then lets you determine the saturation and the lightness. This is a still coming out of Photoshop, and here you can see the color equivalencies. I chose a blue, and in the RGB it has a value of 20, 49, and 197. In CMYK, that's 91% cyan, 83% magenta, and no yellow, and no black. Now in Photoshop is calling HSL HSB. It's really the same thing, and you can see that a degree is chosen at the top, identifying the hue, and then there's two percentages identifying the saturation and the lightness. The next component of design that you should be aware of is measurement systems. Print and web design do not use the metric system or the imperial system that we generally use here in the United States. So let's take a look at some of the measurement units that are commonly used in design. The first is pica, which is 1/6 of an inch. One pica is represented as 1 p. There are points, which are 1/12 of a pica. One point is represented as 1 pt, and you're probably familiar with this from programs like Microsoft Word, where type is measured in points. We've talked about pixels, and because the pixel is the smallest block of color that can be shown on a digital screen, designs created for the web, tablets, and TVs are measured in pixels. There's also a measurement known as M or EM, and 1 M consists of 16 points and is used to space elements on websites. The next component, and probably the one that is the most detailed, is typography or font styles. We'll go over some terminology, some elements critical for display and style, and some conventional elements regarding the media you're going to be presenting your content for. Let's go over some of the common typography terminology. Character is used to define or to identify a letter, number, or symbol. So 1, P, Q, these are characters. Glyphs are the specific shape or path of characters. So in one typeface, the S might have really swooping angles, whereas on another it might be less swooping and more straight up and down. Each of those is a different glyph. A font, the word font refers to a set of complete glyphs. Typeface refers to a style of font, and here's where I think it gets a little bit confusing. A lot of times font and typeface are used interchangeably, but they really are not the same thing, and understanding the difference is a little easier if you go back to the days of movable type. Back when printing was still done with lead letters that were specially forged and then lined up in a press, typeface referred to a style, so a specific set of glyphs, whether the S was really swooping, whether the G came down really far, whether the T was really tall, what have you. Each typeface had its own set of glyphs that were specific to it that matched each other within the set, and typeface just referred to that set of glyphs. Font referred to a complete set of glyphs of a certain size and weight. And font comes from the name of the drawer where the font would be stored. So in movable type, if you worked in a movable type foundry, you might have drawer upon drawer of lead or wooden letters that had been pre-made that you could pull out when you needed them. So if you were in your movable type printing press area and you needed to print something in 12-point Helvetica bold, you would go to the rack with the typeface Helvetica and you would look for the font drawer that had the bold 12-point. So the difference between font and typeface is that font is more specific. It refers to the specific size and weight of a typeface. Next, let's talk a little bit about serifs. Serifs are the little tags on characters, and the type used in this presentation is sans serif or without serifs. So you don't see little tags on the edge of the letters. But if you look down at Ball State University, you can just almost see these little tags on the letters coming off of the T and the U. Or over here at Knowledge Network, you can see the tags sticking off the top and the bottom of the N and the T, for example. Proportional fonts are fonts with different widths. So fonts where each character has its own width. Monospace fonts are fonts with the same width. So fonts in which each character gets the same width regardless of what character it is. And we'll look at an example in the next slide. Aliasing refers to distortion on the edges of type, which used to be very common on computer screens, where computers are using pixels, which are squares, and we're trying to represent curves and shapes through those pixels. It does what's called aliasing. Anti-aliasing is a filter that removes this distortion, which is why you're probably not seeing it now. Finally, weight refers to the boldness of character lines. Let's look at some examples. So characters, these are all characters, A, B, C, parenthesis, period, colon. This is a glyph, S. The specific version of this S in the exact shape that it's in with the swoopy top and the swoopy bottom and the tags on the top and bottom and the thick middle part. Font or typeface, Times New Roman is a typeface. Times New Roman 12-point bold is a font. So typeface refers to each set of glyphs. So the Times New Roman glyphs have serifs and have some thick areas and some thin areas. The Arial typeface glyphs are uniform in their thickness across all letters, and they do not have serifs. Next, we have a proportional font where each letter is a different width. So you can see the I takes up a little bit skinnier space than the W, for example. The W is real wide. Monospace, here's an example of a font that is monospaced. Each letter gets the same width. So the I is really spread out, and the bottom of the I comes out really far to the left and right in order to fill the same width as the W fills. Weight, again, is boldness. So here we have bold word. Aliasing, you can maybe just see some distortion on this type that says distortion. And then anti-aliasing, we apply the filter and it gets rid of that distortion. Now here's an example of serif and sans serif. Sans means without. So in the serif font to the right, we have those tags that stick off the edges of the letter, and in sans serif, we do not have those. Serif fonts are an older style of font, and they are meant to give the hint of handwriting. Whereas sans serif fonts are more modern, and we get rid of that little hint of handwriting in order to create a letter that doesn't look like it was handwritten. Now that we have a vocabulary to describe the elements of typefaces and fonts, let's talk a little bit about how we display them. Kerning is the space between character pairs. A good example is A and V. Because the right side of the A slants to the left and the V comes out and slants to the left as well, we want to push those letters together a little bit closer so they are not quite as far apart as they would be without the pushing. That pushing together that's called kerning. The space between character pairs is called kerning, and when we push letters together, we kern them. Tracking is the space between characters. Leading is the space between lines of type. So if you have a paragraph that's 4 lines, the space between each line is called leading. And again, that's a term that it helps to have a understanding of movable type. Back when type was still made in these foundries where people would have to pour lead into, carve or pour lead into the shape of letters, they would create these strips of lead that would separate the lines of type. So they could set up one word or one sentence, one line, and then they could put a strip of lead and then put the next line under it and then a strip of lead and then the next line under it, and then they would have a paragraph. So leading refers to that space between the lines because it used to actually be a strip of lead. The baseline is the bottom line where the text sits. The cap is the height line of text. The midline is the middle line of the text. And let's take a look at how all that works. You can see the baseline is where the letters sit. You can see the cap height and the median, or the midline. And in this example, we can see kerning. The word kerning to the left is normally spaced. The word kerning to the right, each letter is spaced out. Again, tracking, you can see the spacing. Here with leading, the first example that says leading lines, we have a close or tight leading, so the lines are very close to each other. And in the bottom example, we have a loose leading, so the lines are farther apart. In this slide, you see several different typefaces. Some are serif, Times New Roman, Garamond, Georgia. They have the tags that hang off the edges of the letters. And some are sans serif, Arial, Helvetica, and Tahoma. And here you can really start to see how each typeface has its own character because the glyphs that make up the typeface are different. So Times New Roman has a very traditional look. It is meant to look, because of the serifs, a little bit more like humanistic. Arial, Helvetica, and Tahoma do not have the serifs, and they're made to look more modern and industrial. And then you can start to see some other differences between these typefaces. Garamond, for example, looks a little bit more handwritten, the way the A has kind of a sharp upturn of the counter at the bottom where you have the A here. This right here is upturned kind of sharply, almost as if it had been handwritten. So when talking about typography, it's important to know the definitions that help us understand the different parts of the type, but it's also important to keep in mind that each typeface has its own character, and the elements of type help give that character. So Arial, Helvetica, Garamond, Tahoma, Georgia, they all give off a little bit different vibe.